Good afternoon, all of you. So this is the second lecture of sequencing. I hope you all have listened lecture number 1 and you have understood how to solve sequencing when n jobs and 2 machines are there. If you have not listened lecture number 1, I request you all to listen lecture number 1 and then see this lecture number 2 for your understanding purpose. So now, today's second lecture we will be starting with n jobs, 3 machines. N job, 3 machines or 4 machines. Okay. So the problem is 8 jobs are to be processed under 3 machines. 8 jobs are to be processed under 3 machines in the order CAB. See, order they have given as CAB, which is very important. Processing times in hours are given and we have to find out what is the optimal sequence, total process time and machine idle times. So this they have given the question. 8 jobs are given, A, B, C, the processing time in hours is given. What is the first step? The first step for such problems is we have to write down the order first. 8 jobs, order given is CAB, so write the order first machine C, A and B. Now, what is Johnson's algorithm? Johnson's algorithm is applicable only for n jobs and 2 machines. But whenever more than 2 machines are there, 3 machines, 4 machines or 5 machines, whenever more than 2 machines are there, in that case we have to check 2 conditions. There are 2 conditions. So, if any one condition is satisfied, then we can convert this 3 machine problem into equivalent 2 machines. Convert it into equivalent 2 machines, then you apply the Johnson's algorithm. Otherwise, you cannot apply Johnson's algorithm. Correct? So, what are the conditions? The 2 conditions. Before checking the conditions, see here, do the markings first. See the first column and the last column. If 3 columns are there, this is the first, this is the last. Correct? On the first column, mark minimum number. The minimum number is 2, so we mark this minimum number. First column, minimum number. Last column, minimum number. It is 7. So you put a square mark here. So 2 minimum numbers I have. On the center column, there is only one center column. If 4 machines are there, there will be 2 center columns, and for both the columns we have to mark maximum numbers. First column, last column, mark minimum numbers. Center column, mark maximum numbers. So the maximum number here is 7. I have put a mark here. This is maximum. Correct? Now, what are the conditions? There are 2 conditions, out of which at least one should be satisfied. What are the conditions? Check here. First condition, minimum of C means first column. The minimum of this should be greater than or equal to maximum of this. Minimum of column 1 should be greater than or equal to center columns. Center column is only 1. Or minimum of last column should be greater than or equal to center columns. Out of these 2 conditions, if one is satisfied, then we convert 3 machines into 2 machines and then apply Johnson's algorithm. If both conditions are not satisfied, then you should clear cut write. This problem cannot be solved by Johnson's algorithm. You have to stop the problem. So the 2 conditions I have written here. Minimum of the column number 1 is 2. This should be greater than or equal to center columns. Center column is 1, I have written here. If 2 center columns are there, 2 numbers you have to write here. So this minimum should be greater than or equal to both the 2 numbers. Or second condition, minimum of last column should be greater than or equal to center columns. Or 7 should be greater than or equal to 7. 7 should be greater than or equal to 7. Second condition is satisfied. If out of 2 conditions, if one condition is satisfied, then we can convert 3 machines into equivalent 2 machines. 3 machines can be converted into equivalent 2 machines. What are the names of 2 machines? Machine G and machine H. How to convert that? Machine G is equal to C plus A, machine H is equal to B plus A. How I have written this? Just check here. Machine G. What is machine G? Starting from the first machine. First machine is here C. Starting from the first till the end, leaving the last column. If 4 columns are there, for example, A, B, C, D. What is machine G? Starting from A till C. Leave the last one. This will be machine G. So here I write machine G. Means 5 plus 4, 9. 6 plus 6, 12. 3 plus 4, 7. Like this you have to write. For machine G you have to write such timings. What is machine H? Starting from last, leaving the first. Starting from last, leaving the first. See, this is machine H. Means 8 plus 4, 12. 10 plus 6, 16. Like this you have to write. If there are 4 machines are there, machine G will be A plus B plus C. Leave the last column. And machine H will be D plus C plus B. Machine H. Like this you convert 3 machines or 4 machines into equivalent 2 machines. When equivalent 2 machines are there, which I have done here. See here, all of you. 8 jobs are there. Machine G, machine H. C plus A, B plus A. Write the timings. I have told, add the timing of C plus A, we get 9. Like this you write here. Add the timing of B plus A, write the timing here. Now we have converted 3 machines into equivalent 2 machines. When we get 2 machines, we can apply Johnson's algorithm. In lecture number 1, we saw how to solve a 2 machine problem. Now, using the same method, we have to find out the optimum sequence. Correct? We have to find out the optimum sequence. Now, how to find out total idle time? How to find out total processing time required for all the jobs? When we get the optimum sequence of the jobs in the block, in this block like this, we have drawn the block. In the block, if you get the optimum sequence, this optimum sequence we have to write in the next table. This is the next table. Write the optimum sequence, and here see what order is given. Order C, A, B they have given. So we have to write once again C, A, B. Machine G and H, we write like this only for finding out the optimal sequence. Once we find the optimal sequence, once again we have to write same 3 machines but in the given order only. Given order is order C, A, B. For C, time in, time out. For A, time in, time out. For B, time in, time out. How to write the time in, time out for each machine? We have studied in lecture number 1. So accordingly you have to find out, write down the optimum sequence here. Time in starts with 0. What is time out? The processing time of this job plus get time out. So like this you go on writing the time in, time out for all the machines, and the last timing that we get here, this timing is the total processing time required for processing all the jobs on the 3 machines C, A, B. This is the total processing time. So this detail we have studied in lecture number 1. So I tell you, first listen lecture number 1 and then go for lecture number 2. Okay, here we end the numerical, all of you. Thank you.